Okay. So Faraday's law is whenever current carrying conductor is placed in between the magnetic field, an EMF is induced. That is what. Okay. So here in induction motor, what is current carrying conductor? That is what the rotor conductor. The rotor conductor. It is placed in between the stator magnetic field. That means rotating magnetic field. So whenever the current carrying conductor is placed in between the magnetic field and induced the EMF is produces. That induced EMF is inducing current in the rotor bars. So this is what happening in a induction motors. Okay. So here the relative speed between the rotating flux and the static rotor conductor is caused the current generation. So as per Lenz's law, the rotor will rotate in the same direction to reduce the cost. That means relative velocity. So this is what the working principle of three-phase induction machine. Um, if speed becomes, for example, we know that what is synchronous speed. Whenever a current, that means the AC supply is given to the stator winding, a rotating magnetic field is rotates at particular speed. That is what called as synchronous speed. Okay. So if the synchronous speed is equal to the rotor speed, or else rotor speed is equal to the synchronous speed, so the motor would not able to run. The motor will not able to rotate. How? So this is my questions to all of you guys. That means what if the rotor speed is equal to the synchronous speed of the rotating magnetic field? That is what the question. Okay, the answer is here only. So if the speeds become equal, there would be no such relative speed. Okay, so the rotor speed, that means initially we are given three-phase supply to the stator winding, so it will produce a rotating magnetic field. So that rotating magnetic field is placed in between them, that means rotor current, rotor bar. Okay, so due to that the flux is produces, that flux is induced EMF, that induced EMF is inducing current in the rotor side. So the rotor is start to rotate. This is what happens in the three-phase induction machine. So once the rotor is trying to catch the synchronous speed, that means the rotor start to rotate as the same direction of the synchronous speed of the rotating magnetic field. Okay, so both running in the same direction. So this rotor is trying to catch up this synchronous speed, but it wouldn't able to catch up. So that is why it is start running. So there is no need starters. There is no need starters. This is what happening in a three-phase induction machine. Okay. So here the question is, if the what if the rotor speed is equal to the synchronous speed, means both coming like both, if both are equal, there is no inducing current. So once there is no inducing current, there is no torque is produced. So once there is no torque, the motor is not going to rotate. This is what happens. So if the speed becomes equal, there would be no such relative speed. So no EMF is induced in the rotor, no current is inducing. Therefore, no torque is also going to generate. So this is why the rotor cannot reach the synchronous speed. Next thing is slip. Actually, slip is a difference between synchronous speed as well as rotor speed. That is what called as slip. So this is what the basic principle. Anyhow, I just recall the basic principle. That means when a three-phase, first step is when a three-phase supply is given to the stator side, a rotating field is produced in the stator side. Okay, so that stationary rotor, magnetic field is rotate in the stator. Statorல இருக்க magnetic field வந்து rotate ஆயிட்டே இருக்கும். But that rotor is stationary here. So magnetic field is rotating. So the stationary rotor cut the revolving field, and due to the electromagnetic law of induction, an EMF is induced in the rotor conductor. So அந்த ரொட்டேட்டிங் மேக்னெட்டிக் ஃபீல்டு இதை கட் பண்றதுனால ஒரு இஎம்எஃப் வந்து இதுல ப்ரொடியூஸ் ஆகும் ரோட்டர் பார்ல. ஓகேங்களா? So as the rotor conductor is short circuited, current flows through them. So since this rotor conductor, we saw about screw cage, the rotor conductors is short circuited. Am I right? So once it is short circuited, the current is induced, or current is flows through them. So it becomes current carrying conductor is placed in between the magnetic field. So how will it become means, so current carrying conductor is placed in between the magnetic field. So it start to rotate. The torque is produces. So this is what the principle. So I repeat once again. First three-phase supply is given to the stator side. So rotating magnetic field is produces. So what is rotating magnetic field? That I will